Hello, going to be doing session three's lab today. So let me just pull up the lab. So we're going to be looking at help 32 in Binary Ninja today, and we're doing some code analysis. Um, so the lab starts off with being asked to see what registry key value is being set. So I have Binary Ninja pulled up and I'm in the triage view that we saw within the session. And the first thing that I'm going to do is to go to the imports here and search for the registry set value. Um, and so this is the registry set value um, extended function API. So let me go in the code to where it's called. You can see I added some notes here. Um, and I actually pulled up uh, the reg set value extended a function that we're looking at in the code. And the main thing that I want to look at here is what, well, one, what key are we setting and what value is it setting? So um, off the bat, um, I noticed we want to look at LP value name, which is the name of the value to be set. And I also noticed that LP data is what is being stored for that key. And so it jumps right out pretty easy for what the value is. Um, it's right here in the code. It's disable task manager, which seems to be pretty straightforward. It's just going to disable task manager. And now we need to look at LP data to see if it's setting that to maybe 0 or 1, I would expect. And so when I click on LP data here, a couple lines up, I see that it's actually being set to uh, the address of var underscore 138. And then when I click on that, I see a couple more lines up that this is a 32-bit integer that's being set to 1. So I would assume, now that we know, what this value is, what the data that's being stored in that key value is, we can make the assumption that this registry value that's being set is to enable disable task manager. Again, so I have written comments for that, calling out that LP data is being set to 1, and that's what reg set value uses in conjunction with the actual key within the registry. So that was that part of the lab. And yep, I had written that this most likely disables Task Manager, preventing visibility of a common utility tool to monitor processes. So I'd assume this is some sort of malware running that we're trying to kind of evade any kind of detection. Right, most systems typically use Task Manager, or most administrators, system administrators might use Task Manager to see running processes, what processes are maybe using a lot of resources, and so this will kind of turn that off to help evade. Next part of the lab was saying it was asking what function is actually collecting users' clipboard data. So I'm going to go back to the triage summary, and same spot that I looked up the reg set key, I'm just going to type in clipboard. I remember that some API functions like this existed, such as open clipboard, close clipboard, get clipboard data. I'm going to double click that, and then I'm going to go to the code reference for that. Um, and you can see right here, get clipboard data is being called. And if we scroll up to see what function this is a part of, it seems that it's a part of this um, sub 14011AB00 function. So that answers that question. And then the next part was being asked to search in the code for the Telegram address that we saw in in previous sessions. Um, so I'm going to go back to the triage summary since it seems very valuable to kind of have like a pane of glass for a single pane of glass for everywhere we want to kind of pivot in the code. And I'm going to start, and I already did it. I searched Telegram and I could see that this URL pops up. So let me just go in the code where that's called. And you can see right here that this Telegram link is being called this api.telegram.org/bot. And you can even see a line before that. We have this send document and a chat ID. So it seems like this is some sort of info stealer. But this is a part of this sub 14011B7D0 function. So we called that out in the lab write-up. The next thing we were told to do is to run kappa on the code or on the file. It took almost 40 minutes to run kappa, um, but we were asked to see within the output um, what persistence capabilities are being ran, and I went through all of them. Um, Very cool tool. It kind of shows obviously all the different potentially malicious things that are being done that we can kind of again pivot into looking in our code analysis. And these last two things kind of caught my eye. More specifically, this bottom one here, which is saying write file to startup folder, right? That's definitely persistence, and it even calls it out here, persistence as a function. So, or as in the function. Um, so let's go to this address. I'm going to do Control G or G, and I'm going to punch that in. And where are we? Yep. So what I have noticed is the use of, or the code seems to be um, getting file names, getting some folders. I'm assuming it's looking for the startup folder there. And it seems to be placing this svchost.exe um, into this startup folder. And we're lucky that we even have some strings here that says executable added to startup folder. And it even has some error debugging where it says error copying this executable to the start folder. So we know that, and you can see copy file A here. So we know that just by looking at the use of these functions and through the help of some strings that we luckily have, we could tell that there is definitely a file, and in this case, an executable being added to that start folder. And kind of going back, we were seeing what the executable was. It seems to be that service host. Um, and let's see if we can find anything else here. Okay, so it even has an error report if it can't get the program path. But this seems to be mainly what this sub 14012E130 function is doing. And it is definitely doing some sort of persistence, so we can definitely confirm kappa's um, alert. Anything else I wanted to call out on this? I think that's mainly all I wanted to bring up. Although I want to quickly look at what service host really does. It runs a background service host. So not sure. Maybe we could poke in here real quick. Might have to do a deeper dive, but I don't think service host alone is malicious. but it seems that uh, maybe some sort of command or arguments being ran to it um, to be executed by service host in the background on startup. So some additional code analysis will need to be done there, but we could definitely tell that this malware is doing some sort of um, execution in the background and persisting it. Okay. Time am I at? Okay, I'm at 10 minutes. The other part of the lab here is asking to find another additional interesting observation in the code. Um, and so I was just kind of playing around within Binary Ninja, looking at strings, looking at code references, just kind of bouncing around. Obviously, I used Kappa as well to kind of look for things, but one thing that I did catch um, is in this function. Let me see if I can search it up. Can I go to it? Yeah, this one. So what I noticed here is the use of these bitmap functions, and I pulled up um, the MSDN um, for bitmap functions, and I see a lot of them called in the code here, and I'm just kind of poking around, and um, it seems that what we're looking at in the code here is it's creating a bitmap and then saving that to a file. Um, you could see here, you could see some of the paths of where this file is being saved, this temp runtime. You can see it's then kind of even calling it pick and then, or a pick directory and then this image PNG. And what I'm thinking is going on here is, and you can even, and it'll be kind of confirmed later in the code, but it looks like it's kind of running these Windows Win APIs to build this bitmap, which is essentially taking a screenshot. And again, we're lucky with some strings in the code here that even kind of confirms that, where we see failed to save the screenshot save to, which would probably obviously uh, be a string which is appended with the actual file location, and I'm assuming that location will be what we saw earlier in that temp directory. But it's saving a screenshot of the user's screen, of the user's process. And right, what we were looking at earlier with Telegram, we could then make the assumption that this is a part of that info stealer, gathering these screenshot images via bitmap functions to send over the wire through Telegram to a control and command server or command control server or whoever. Um, so yeah, pretty cool to hop around the code and look at some of these things um, and kind of further validate that this definitely is something malicious. Um, so yeah, I think that's all I really wanted to record. So um, thanks again, Anuj.